some examples of random variables and why do we need random variables. And we mentioned that in many cases, we are not really interested in the outcome itself of the experiment, rather than we are interested in some numerical values of that basically measure or that translate the outcomes into numerics. This has several reasons. The first one is, in many cases, two experiments might have the same statistical distribution, I would say. We'll come to these statistical distributions. For example, as I mentioned, the results in the exam, for example, 315 exam, the first one, this is an experiment. It might have certain distribution. For example, like this, with the average and the standard deviation and so on. Okay? Now, you can have another exam, and if the exams are standard, you might have another exam, the second major exam, for example, which has the same distribution. So without looking at the specific outcomes, you end up with the same distribution. So in order to analyze the outcomes, the statistical behavior of this exam, I don't really need the specifics. I don't really need the specifics of the outcomes of the experiment, which are the scores. I need how does this distribution look like. So several experiments might end up with the same statistical behavior. So knowing how to deal with this statistical behavior, اللي هو distribution مثلا, الكيرف اللي تسموه, this will help us analyze, predict, and so on, without even knowing what is going on inside the experiment itself. So it's very useful for us if we can get away from the outcomes themselves and work with the numerical values that translates the outcomes. Okay, as we go, these ideas will become, inshallah, more clear. So the whole idea is to cast the details of the random variable, the outcomes, into the real line. As I mentioned, this helps us in making the whole probability theory more than numerical, mathematically easier to deal with, and standard. So different experiments with the same statistical behavior can be treated the same without delving into the details of the experiment. For example, what do we mean by random variable? Random variable is a mapping between the sample space and the real line. Let's see how. For example, tossing a coin once, you can have a head or a tail. So in this particular example, we will translate head into 0 and tail into 1. So this is basically the sample space. We have head, we have tail, then head basically, if this is the real line, then head goes to 0 and tail goes to 1. Okay. Another example, tossing the same coin 3 times and observing the number of heads. In this case, you can see that the number of heads can be what? Either 0, right? So when you have tail, 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 you map this into 0. When you have head, tail, tail, or tail, head, tail, or tail, tail, head, you map them into 1. So this is here. We have several of these. Tail, tail, head, and head, and head, sorry, tail, head, tail, right? And when you have head, head, tail, and its sisters, which is basically the permutation of this, you end up with 2. So the random variable here can have how many values, Shabab?
Excuse me, doctor, how did we come up with 0, 1, and 2 corresponding to the head and tail? The 3 ones that hit tail, we correspond them to the line with measurement of 0 to 2.
Yeah.
Can you repeat that?
When you toss a coin, so we are talking about the example, second example, not the first example. When you toss a coin 3 times and observe the number of heads, then how many heads you can have out of 3 tosses?
Maximum 3.
And what are the numbers? You can have nothing. So all the time tails, tail, tail, tail.
1, 2, 3.
Yes, so tail, tail, tail is mapped into 0, right?
Okay.
Head, tail,
Tail is mapped to 1.
and
head,
its
head
sister,
mapped
and the
to-
sister, tail, tail, head, and اللي هي البرميتيشنز حقتها is mapped into 1. And head, head, tail, and its permutation ثلاثة منها is mapped into 2.
2.
Clear now?
Yes.
تمام. So basically, here we casted the whole thing into the real line. And now we can deal with this. We will define later what the distribution function is, what the
Excuse me?
probability density function is, and so many things. تفضل.
زاد فضلك. I believe we are missing head, head, head.
Yeah. Head is here. I agree معك. Which maps into كم؟
3.
ممتاز.
3.
Excellent. So basically this goes from 0, 1, 2, 3. نمسح شوية ننظف اللي هنا. Thank you. Thank you very much. طيب. So basically instead of worrying about the set itself and the events and these head, tail, tail, and so on, now we have a random variable that has only 4 values. We can measure its or calculate its probability density function, as we will go later. Probability distribution function, we can measure the mean, اللي هو average, standard deviation, so many things. Because now everything is numbers. Rather than before, it's basically details of the outcomes. Another function, random variable, sorry, is the a real random variable x is a function that assigns a real number, نسميه x of s, to each outcome s in the sample space. So here we have, in the sample space, we have s, s1, s2, s3, okay? So basically a number for every s is assigned in the sample space. If we have a set x, then basically we assign sx, which might be a range in the real line. Sorry, not x. Let's remove x. A certain set. Then basically this certain set can take a period within the real line. Okay, so S here is the domain of the random variable. So the random variable is a function, huh? Is a function. The function عنده ايش? Domain or range. The domain of the random variable is S, which is a sample space. The range of the random variable is the real line or a subset of the real line. Okay. So here we have a mapping from S into the real line. The domain is the sample space. The range is, in this case, Sx, which is basically the part or the subset of the real line. So before we go to the next point, any question about what a random variable is?
Clear, Doctor.
So let's have some examples. Now we are defining here an example which is rolling a die and tossing a coin. And the random variable is defined according to the following. It maps the head outcome to the positive line of the real number, which corresponds to the dots in the die. يعني إذا طلع لي head, the random variable إيش يصير؟ Equals to the number in the head, sorry, the number in the die. So if I have head here, the random variable value equals the number that comes out of the die, at the surface of the die. If I have tail, on the other hand, the random variable equals double the negative number, double the minus sign that comes out of the die. Okay, so the head here is mapped into the positive part of the real line, and it's equal to the number that comes in the die, out of the die, and the tail maps into the negative part of the real line, where the number equals minus that of the double the number that comes in the die. This is another random value. It might be useful, it might be useful. Okay. A third example is the wheel of chance. Wheel of chance from 0 to 12. لو تتذكروها. So the S here is 0 to 12. You can get any number from 0 to 12, a real number. So you spin the wheel and it rotates until it stops. It can stop at any real number between 0 and 12. Now S here is the outcome of the wheel. And the random variable x of S is defined in this particular example as S squared. Okay? So the random variable here maps the numbers, maps the S, which is 0 to 12, into numbers which are 0 to 144. This is a third example. For example, one example in our electrical engineering, which is the voltage that you measure out of between around a resistor. So you get voltage, right? Now this voltage is a number that might take from 0 to 5 or whatever. Maybe I'm not interested in the voltage, in the details here. I'm interested in the power, right? So I define the random variable in this case to be كم power?
V squared over R.
V squared over R. Okay, so in this case, the random variable might be V squared over R. Okay. Now, not necessarily that the sample space maps uniquely. بمعنى إيش؟ Like here. So basically, x of S might be the absolute value of S, the S square, and so on. So two values of S, more than one value of S of the sample space can take the same value in the real line. One example was here, the number of heads. Here, 3 of them are mapped into one value. The same thing, the other 3 here are mapped into 2, which is another one value. So multiple sample space elements can map into one value in the real line, which is a typical function. However, the random variable cannot be multi-valued. بمعنى إنه one value in the S cannot be mapped into 2 values. This is wrong. In this case, this is not a function. صح ولا لا? Function cannot have 2 values for the same value, for the same
1 to 1.
1 to لا يا 1 to 1 يا multiple to 1, but not
Yes.
not 1 to multiple. يعني انت you cannot have a function يكون عندك شكله كذا. ما في شيء زي كذا. يعني for every x you can have several y ما ينفع. لكن you can have a function that looks like this. For every several x's you can have the same value. واضح؟ So
Yes, clear.
random variable cannot be multi-valued. The opposite is okay. هذا طبعا definition of the function. A function means that you map from 1 to 1 or from multiple points in the sample space to 1. But it cannot be the other way around. This is not a function. أول مثال x and y يعني يكون x لها كذا value في y doesn't it's not a function. ما لها معنى.
Excuse me, doctor. And
تفضل.
it should have just one value. It cannot possess two values at a time, right?
Yes.
But can there be? It can have two or more values, but cannot not at the same time. Is it possible, or are we going to take that?
ايش قصدك not at the same time?
I don't know. Maybe just like a clock, or it will have different values, or like this complex, questions. Sometimes it will have more than value, and they will add up or something.
لا يعني هي random variable as simple as this. It maps S. This is the domain. This is the range. Okay. One point in the domain cannot take more than one point in the range. It's a typical function. زي ما درسته في الكالكولس. Otherwise, this is not a random variable. This is something not defined mathematically. خلينا نقول.
Okay, I see.
You can define anything in your life, but does it make sense mathematically or not? That's a different question. طيب. So this is the first point that I would like to make. The second point, now the value is x less than a specific x. Now this is the notation. X here is what, شباب? The capital X is the random variable. We should write it as x of s. Sorry. But x of s, why? Because this is the element from sample space, right? And x here is the function or random variable, right? But from now on, we will not write the s, just to simplify notation. Simplify notation only. But you need to understand that every time we write capital X, it means that it's a random variable, which means it's a function of the sample space, the elements in the sample space. Okay? So from now on, we will not write X of S. We will only write X. X means it's a random variable. واضحة؟ Okay?
Yes.
So now the X less than X. So here, let's take this example. X less than or equal 0. What can we say about this? In this particular example, هذا example. يا شباب, what corresponds to x less than 0? ايش equivalent to that? متى x is less than 0 في الإكزامبل اللي فوق؟ نعم؟ صوتك مو واضح.
If the coin is tail, the x will be negative.
When what?
When the coin will be tail.
Yeah, when the coin is tail, exactly. So here, this is basically happens when tail and 1, tail and 2, right? Up to tail and 6, right? So x is less than 0 corresponds. This is an event, or yes, an event in x in the range, in the function, and this is the event on s. So here, this is defined on S, a corresponding event, and this is defined on X of S, which is the function. Now, these are equivalent. Now, in order for me to find the probability of X less than or equal to 0, ايش رايكم؟ كم هذه البروبابيلتي؟ شباب
Yes, doctor. 0.5.
What is the probability of x less than 0?
0.5.
Why?
half
because it contains half the elements in S, right? Which is equal to 6 over 12. 6 elements out of 12 possible elements.
دكتور can you hear me?
Yes, توني اللي سمعتك أول كذا أول ما كنت. Okay? So now
دكتور.
تفضل عندك سؤال؟
اوكي عشان اتاكد انك سامعني كنت
لا
اجاوب
سمعت.
ما كان في اي استجابه.
إيه لا ممتاز ما كنت سامعك معليش. شكرا. So basically when we say probability of here capital X less than a number X, we need to understand that this capital X is the random variable, while X here is a number. Small x is a number, and we will use this notation all over again and again in this course. So the small x here is a number, the capital X is the random variable. So when I say the probability that capital X, which is a random variable, is less than or equal to small x, a number, this is equal to the summation of the probability of all elements in S that satisfies this condition اللي هي تخلي x less than or equal to x. Let's see this example. Tossing a coin 3 times and observing the number of heads. Okay? نحن قلنا انه this gives you what? Either 0, 1 or 3. صح? Now when I have 2 heads, these are the part of S that has 2 heads. They are all mapped into 2. And 1 is a mapping of 3 different elements, which are head, tail, 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 head, tail, and so on. And 0 is mapped from what? 0 comes from the tail, 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 right?
Right.
So now when I say x less than or equal to 1, this is equivalent to the elements that gives me x equals to 1 and x equals to 0, right?
Right, which is tail, tail, tail.
Which is tail, 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 هذه equivalent to this. X equals 0 equivalent to tail, 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 and x equal to 1 equivalent to the rest. Okay.
اوكي دكتور.
دكتور يعني الهيد equivalent to 1, right?
نحن هنا tossing a coin 3 times and observing the number of heads. So the way we did it is we count the number of heads and we give it a number. We map it into a number on the real line. فعندنا random variable x can take 0, 1, 2, 3. صح؟
صح.
When is the random variable less than or equal to 1? هنا كذا ويسار.
Right.
When it is equal to 1 and or it's equal to 0. So this is equivalent to x equal to 1 or x equal to 0. X equal to 0 happens when you have tail, tail, tail. X equal to 1 happens when one of these 3 outcomes occur. So this is equivalent. These are 2 statements that are equivalent. Now, if I want the probability that x is less than or equal to 1, احنا آخر شيء عرفنا random variable what? For what? To be able to manipulate, analyze, predict, study, understand the behavior of the random variable. صح ولا لا? The behavior of the experiment. So I can ask all these sorts of questions. For example, what is the probability that x is less than or equal to 1? Now this is equal to the probability of the corresponding events, which is the probability that you have one of these 4 outcomes. And since these 4 outcomes are mutually exclusive, it's equal to the probability of head, tail, tail, plus the probability of tail head tail plus the probability of tail tail head plus the probability of tail tail tail, because they are mutually exclusive. واضح شباب؟
واضح دكتور.
واضح.
So basically, this is the first thing that we'd like to mention about. So we need to understand what corresponds to when we say an event x less than or equal ولا larger than or equal ولا equal to كذا number معين. We need to go back to the random experiment and see what are the corresponding events and calculate the probability accordingly. وطبعا راح حنيجي على الكلام هذا بتفصيل أكثر when we talk about the distribution function and so on. The last comment or condition about a random variable is that the probability that x equals to minus infinity should be 0. And the probability that x equals to infinity should be 0, which means that the random variable, the probability of the random variable being at very, very small number and very, very large number dies off, becomes very small. So x can be very, very small and can be very, very large at infinity or minus infinity. However, this happens for a very, very small fraction of x. So it has a probability of 0. Okay? Shabab, any question so far? Let's have one example. Just one more example. خلينا ناخذ ال wheel of chance. هذا wheel of chance. Where basically S here is 0 to 12. Okay? And I'm interested in, give me now, for x less than or equal to 0. What is the corresponding equivalent in S? ايش رايكم؟ بس خليني اوضحها شويه. هذه open interval ها؟ What is the equivalent set in S to this random variable set value? Phi. ليش؟
أي دكتور.
Yes, phi,
don't
exactly. Because
negative value.
Zero.
yes, because S doesn't have a 0 or a negative value. So this is phi, excellent. What about x less than or equal؟ طبعا احنا عرفنا هنا الاكس كانت لو تتذكروا x of s كانت s squared بس عشان نتذكر. So the random variable is the square of the value that you see on the wheel. What about x less than or equal to 2؟ ارسلوا لي على الشات شباب. لا تقولوها هنا. What is the value? What is the set in S that corresponds to x less than or equal to 2؟
دكتور الأول ما كانت اكس سكوير، كانت توايس ذا نمبر مو سكوير.
انا هنا مختارك سكوير. It's okay. This is another example. Fine. مع انها كانت سكوير اتذكر بس يعني بغض النظر هذا هو اكس. السؤال send me the domain or the part of S that corresponds to x less than or equal to 2. شباب, I'm not asking for the probability here. الشباب جالسين يسألوا لي probability. I'm not asking for the probability. I'm asking, send me the domain in S that corresponds to this part of the range. متى x is less than or equal to 2? When, in which values of S of the sample space? طيب يا شباب ايش رايكم؟ When does x less than or equal to 2؟
Two, 1, 0.
لا هذه ترى ما هو discrete يا شباب. This is continuous.
less
أنا
than
شفت.
square root of 2.
For s is basically less than or equal to square root of 2. Exactly. Sorry. It's the value of s such that كذا أو or نكتبها ممكن كذا 0 to square root of 2. نقفل. واضحة ليش كده؟ Because when when x is square root of t equals when x equals 2, then s is equal to what? Square root of 2. لأن x is equal to s square. واضح يا شباب؟
نبي دكتور.
متى x طبعا x is less than or equal to 2 means that s is less than or equal to the square root of 2. Right? لأنه definition of the random variable لو تتذكر فوق هنا x of s equal s square. So the event in x in the random variable x less than or equal to 2 is equivalent to the values of s that are less than or equal to square root of 2. واضحة؟
I got it.
تمام. الآن لو نبغى البروبابيلتي that x less than or equal to 2 ايش رايكم equal to what؟
Infinity maybe.
ليش infinity؟
Probability when it is less than 2 in the R domain.
Yeah, and this is in the R domain. In the S domain, what is the probability equal to what? Of S less than تونا قلنا square root of 2 صح؟ صحيح يا شباب؟
Yes,
When does
صحيح.
this happen؟ إذا عندي أنا wheel of chance تتحرك من 0 إلى 12. طيب الجزء اللي إلى square root of 2 كم مساحته مقارنة بالمساحة كلها؟ إيش رأيكم؟ It's the square root of 2 over كم؟
range 12.
اللي هو total range 12. Yes. Okay. واضحة يا شباب؟ How did we find this؟ طيب أعطيكم السؤال اللي قبل كذا تكلمنا عنه، أشوفكم متذكرين ولا لا. What is the probability that x equals 4؟
0.
0. Why?
0.
Yes.
It's 0. Excellent. Why? Because it's equal to the probability that s equals كم؟ 2 صح؟
It's equal to yes.
احنا قلنا انه when you spin a wheel you can stop at any number. لكن the probability to stop at a specific number is equal to 1 over uncountable numbers which is 0. كأنه 1 على infinity which is 0. So now this is the probability of x equal 4 which is equal to 0. Equal to the probability that s equal 2. Excellent. So now we know how to translate from the random variable and find the equivalent event in the S and vice versa and find the probabilities. Great. Now let's talk about the types of random variables. You can, until now we have seen at least 2 types, the discrete type or continuous type. Discrete type مثل اللي تكلمنا عنه قبل كده, flipping a coin 3 times and counting the number of heads. ايش طلع لي x؟ either 0 ولا 1 ولا 2 ولا 3 صح؟ or so x here is sorry خلينا نكتبها بال s of x اللي هو range equals the set 0 1 2 3. This is the range. So it's a discrete set. Another example is selecting a number from the positive integers. What is S of x in this case? ايش رايكم؟ مجموعة الأعداد الإيش؟ شباب.
Positive integer.
Positive integers, right? Which is from 0, 1, 2, 3, up to infinity. The number of cars arriving at a gas station. ايش رايكم number of cars arrive at a gas station ممكن تكون
from 0 to infinity
0 1 نفس الشيء, right? Okay, it cannot be negative. You cannot have number of cars minus 1. Or you can have a continuous, like selecting a number, a real number, between 0 and x. So in this case, s of x equals 0,
0 1
to
2 3 to 6
لا and a real number. So it's equal to 0 up to 6. Okay? الspinning a wheel الاكزامبل اللي فوق كم كانت الاكس spinning a wheel؟
زيرو to
ايش
12.
كانت؟ يس 0 to 12 مفتوحة من 0 12 مقفلة. Excellent. Or you can have a mixed random variable. مثلا I'm not interested really in the value of the wheel. I'm interested مثلا في المثال هذا when the wheel of chance is give me between 0 and 6 I assign it -1. When it gives me from 6 to 12 I assign it a specific s. Okay, so here s of x equals to what? Equals to -1 وايش بعد؟ الاوبن interval from 6 to 12 closed from this. Right? So this has a discrete part and a continuous part. This is a mixed random variable. بعضه شوية منه mixed, شوية منه discrete, شوية منه continuous. Okay? So the type of random variable comes from the event that we define. ايش تعتمد على تعريف الرandom variable. مثل المثال هذا. I'm not interested if it is negative, if it is between 0 and 6, I only take it -1. If it is between 6 and 12, I say it as is. It depends on what I want. So it's the same experiment لو تلاحظوا. لكن you can have different random variables defined according to what your interest is. What do you want to analyze? So one experiment, the same S, you can end up with several random variables. مثلا tossing a coin twice, 3 times. You can count the number of heads, you can count the number of tails. صح؟ كل واحد يعطيك a different random variable. Okay, شباب? So for the same experiment, you can define different random variables according to your goal, what you want to analyze. You want to study or analyze. واضحة؟ طيب, the last point that I would like to mention is the distribution function. Now, if we understand how does the random variable work, which is we said that this is from S mapping into the real line. So from a specific range, which is Sx. So this is the domain S, this is the range S of x. Okay. Now, the question will be, how are these numbers in S of X distributed? Is it normal? الكيرف المعروف. Is it exponential? Is it equal? Uniform نسميه. What? How? This is related to what we call the distribution function. How is this probability of total 1? انتوا تعرفوا the probability of S كم equal to what يا شباب؟ What is the probability of S?
1.
1. How is this 1? 1 هنا معناها corresponding to probability that X lies in S of X equals 1. صح ولا لا؟ Isn't it?
Yes.
So how is this 1 distributed among the different values of X? How is it distributed among the different values of X? This is called the distribution function. بصفة عامة. We have two types of functions. We'll talk about them. واضح الشيء اللي نبغى نسويه الآن؟ As we have done in the S, we have found the probabilities of different events, right? And we know that the probability of S, which is the sample space, equals 1, which makes the probability of X belongs to the range equals to 1 also. لأنه هذا equal to the probability of sample space. Now, how is this total 1 distributed among the different values of X? Is it normal? Is it equally likely, uniform? What? So let's see. This information comes from what we call the distribution function. We have two types of distribution function that we'll talk about. Let's have one example here. Flipping a coin 3 times and counting the number of heads. لو تتذكروا, out of the S, we ended up with this S of X, right? A range is equal to 0, 1, 2, 3. So the probability of X belongs to S of X is equal to what يا شباب؟ شباب
8.
لا, the probability that X belongs to S of X
1.
it's 1. It's the total probability. زي ما قلنا هنا probability of S equals 1. تمام? Now, let's see. When we talk about specific numbers, 0, what is the probability that X equals 0? ايش the corresponding event in X؟ شباب
All head.
tail, right?
Head.
Which is 1 over 8. We have 8 different elements here in this, so 1 over 8. Similarly, the probability that X equals 3. It's the probability that you have head. Sorry. Which is 1 over 8. Well, what about the probability that X equals 1? How many outcomes correspond to X equal 1? 3 outcomes, right? So it's 3 over 8, which is equal to the probability that X equal 2. So now we can plot versus X the probabilities. Probability of X. Now you can see that the total of these equals what? Equals 1. So this tells us, at least you can visualize now, how is this total probability distributed among the different values of X. Okay? Now you know that 0 and 1 happen less likely, while 1 and 2 happen more likely, more frequently. Right? واضحة يا شباب? What is the function of distribution function? To understand how is this total probability of 1 distributed among the different values of X. We have 2 types of this distribution function. The first one is what we call cumulative distribution function, CDF. And the most popular one is the probability density function, PDF. We'll start one by one. أي سؤال before we continue يا شباب؟ Any question؟ واضح الكلام كله؟
Yes.
No questions? No doubts? Everything's clear? طيب. طبعا we will not finish this. I will just introduce it. We define the commutative distribution, probability distribution function, which is the CDF, as follows. It's a function. F is a function, capital F بنعطيه, sub X, this is the random variable. يعني هذه function, this is F means the commutative distribution function. Notation شوي صعبة أول مرة تشوفوها. So the capital F means it's a CDF, commutative distribution function. The sub X, capital X, is the random variable. يعني هذا distribution function حق إيش؟ This is for the random variable capital X. And it's a function of a number, small x. شوية دوخ. Now this function اللي هو f sub x of small x. F capital F means it's a CDF. Sub x belongs to the random variable x. Of small x means that this is a number. This is equal by definition to the probability that the random variable x is less than this number. Okay? So here the capital X means indicate the random variable x or y or whatever. The small x indicates the parameter or the value, and the capital F indicates the CDF. Okay? So in our flipping this coin 3 times and counting the number of heads, what is Fx of 2? It's equal to the probability that x is less than or equal to 2 by definition. واضح? Now, what is this equal to? It's equal to the events that corresponds to x equal 2. This is equal to the probability of the events which are x equal 0 or x equal 1 or x equal 2. Right? And since x cannot be equal to 0 and 1 and 2 at the same time, then these are mutually exclusive. Because of that, we write them as the probability of x equals 0 plus the probability of x equal 1 plus the probability of x equal 2, which is 1 over 8 plus 3 over 8 plus 3 over 8, and this is equal to 7 over 8. أي سؤال يا شباب؟ So next time, inshallah, we'll take it from here and continue. Any question? Now, the nice thing about this CDF is that it's a function, and we can plot this function. As you can see here, it looks like this. Next time, inshallah, we'll talk about the details. Any questions, Shabab? Time is up. I think if you want to leave, it's up to you. If you have a question, let me know, please.